A very good morning to all. Today I will start with the lecture 3, that is linear measurement and chain surveying. In the previous classes we have studied that surveying is basically a art of collection of data. Now when we collect the data, it is having a different type of measurement in it, and linear measurement is one of the main part in case of surveying. So today we will discuss about linear measurements and what are the instrument that is used for measuring the length, width, and the areas, and the other equipments too that is we can use at present time. So let's start with the linear measurement. Chain and scales are commonly used to directly measure the linear distance between any 2 points. So that is basically understood that when we want to calculate distance between any 2 points, so at present time what we use tape. Okay, initially tapes were not there, so we use chain only. So suppose this is the ground and this is point A and this is point B, and we want to measure distance between this point and this point. So initially we were having a chain, so we just laid down the chain in between the points and we calculate the distance. But at present we have tape. It is already having a indication of the measurements on it, and directly we can measure that what is the distance between 2 points. But uh, at old time what we have that we are not having that facility, so we have to just count the distance with the help of chain. I will discuss that how it was possible at that time. Okay, so chain and scale were used for calculating a linear measurement, and then maps were drawn on a horizontal plane, and then it is converted with the help of scale. That was also one of the way to calculate the linear measurement. Now next one is, what are the different methods of measuring a linear measurement? Basically we have a four method. The first one is stepping method, and the second one is pesometer, and the third one is speedometer and chain and tape. At present we use this method. These methods are used in a vehicle nowadays, and this was the very old method that we use at old time. Simply when there was no instrument, we used simple foot count to calculate the distance. So that was the very old method. Pesometer, it is a mechanical device which is record the number of steps. So basically it is used in a vehicles. And speedometer is also, because it also calculate the speed of the vehicle. So it is again a mechanical device which is used in an automobile. And the last one is chain and tape, that is used to measure the distance with the help of chain and tape, and this method is basically a more accurate method. So we use tape at present, and when tape was not there, so at that time we used chain. Okay, so that is linear measurement. Now next one is chain surveying and how it is related to linear measurement. Basically chain surveying is in which we used a chain as an instrument to measure the distances. So that is basically a chain surveying that we already discussed in the previous lectures also, that if we have this particular area and there are some objects, suppose these are the objects that is present in the particular area, and we want to do a construction, so we require the details of the area. Suppose this is the one, basically a survey baseline that we have drawn from this point to this point. Suppose this is A and this is B. So this reference line will be taken as a baseline so that we can get the detail of other objects from this line. Okay, so offsets will be taken and all the details will be collected. Okay, so basically this comes under chain surveying, and these distance will be calculated with the help of chain. So that is basically a chain surveying. And in that case, if you want to calculate the area, so in that case the outer points of the boundary will be selected, and area will be divided into triangles. The triangulation is we already discussed in the previous classes also. All the area is divided into triangles. So these triangles sides will be measured, and then Hero's formula will be used and area will be calculated. So that was the basic method that we used initially, but at present we have a very modern equipments. So we are not required to do these all things directly. We can have the values on the instrument. Okay, that is chain surveying. So that I already discussed that in chain surveying, this is the particular area, and this line is basically a baseline, and this baseline is having a what offset to have the location of these objects. It can have perpendicular offset or an oblique offset also. And some of the lines that is running, that is dividing area into triangles. So these sides will be calculated with the help of chain. So chain surveying is basically having a triangulation as its part. Okay. Now what is the basic principle of chain surveying? So, principle of chain surveying is to divide the area into a network of connected triangles. So that we have already discussed also. Now there is a one question that if we have a particular area, this area is always divided into triangles. That we are dividing the area into triangles. We are not taking any other shape. Why? So the answer is because triangle is the most stable figure, and it is very easy to identify three sides of the triangle. So that's why we always adopt triangle figure. So triangulation is the basic principle of chain surveying. So you should remember that what is the basic principle of chain surveying? It is triangulation. Triangulation is basically we measures only linear measurements here. So that is the example here. You can see here that sides are there and this is divided into triangles again. So triangulation is basic principle of chain surveying. Now this is very important, that what are the instruments that we used for chain surveying. So the first one is chain itself. That chain is come in the market either of a 20 meter or 30 meter. Similarly, tape is there and that tape is available in the market with the range of 20 to 30 meter. And then we use arrows. That arrows are used for marking the station points. And ranging rods and peg. Ranging rods are basically used for a ranging purpose. So that we will discuss in the next classes. You can see here that this one is a chain. This is basically a metallic chain. It is made of a metal and it is having small elements that we will discuss in the next slides in a detail. And this is the tape basically that we used at present time, and this is the old metric chain, and these are the arrows. You can see that this arrow is having a particular round shape at the head and it is having a sharp edge at the bottom, and these are ranging rods. Okay, so these are the basic instrument that we have to use during a chain survey. It is very easy that we have to just select the points, we have to just align the points in a straight line, and then we have to just measure the distance with the help of chain. Chain and its type. This question is very important and it is asked many times in exams too. So basically we have four type of chain. The first one is metric chain, engineering chain, Gunter chain and revenue chain. These three chains are very old. At present we have only this one, that is metric chain, and it is 20 to 30 meter available in the market, but it is also replaced with the tape because chain is very heavy to carry and tape is very lightweight and it is very easy to carry. And second thing is that dimensions are measured on a tape, but metric chain is not having any dimension on it. We have to just calculate it manually. So that is very tough in that case. That's why this chain is replaced with what? Tape nowadays. That we will discuss again. So you should know, generally this question is asked, that engineer chain is particularly having only a standard length of 100 feet. Gunter chain that was of 66 feet, and revenue chain that is of 33 feet, and metric chain that is of 20 to 30 meters. So these dimensions you have to remember very carefully for the exam purpose. So you should only remember, because metric chain is widely used and these other chains are not used at present, but you should remember that what are the dimensions, what are the length of these chains. Okay. Now next one is chain detail. So when you will see these chains in a laboratory also, so what you will find that it is having a one brass handle. So this handle is basically made of a brass, and it is having small oval rings. Okay, and these oval rings connected with a link. Basically this horizontal part between the oval rings are what? A link. So in that case you have to remember this basic thing. The first one is the length of a chain is how much? 20 to 30 meter. You can see here that these are the handles and these are the links. It is collected, or it is tied link by link. Okay. Now next one is one link is having how much length? 20 centimeter. So you can have idea that if one link is, sorry, I'm not able to write here. Okay, if one link is of 20 centimeter. Okay, so if we have a 30-meter chain, how many link will be there? You have to just multiply by it and you should get 30. So you can have idea that if we have a 150 link in 30-meter chain, okay, because one link is of how much? 20 centimeters. So you should know how to calculate this number of links. And if I talk about 20-meter chain, so 20-meter chain is having how many links? 100 links. Okay, so one link is of how much? 20 centimeter, and that is the standard length. Oval brass ring, and oval brass ring is present at a 1 meter. So you can have already, you have idea that 30 meter is having how many links, 20 meter is having how many. So obviously you can easily calculate that 1 meter is having how many links? 5 links. 5 link is equal to how many? 1 meter. So after 5 link there is a one oval ring. This oval ring is representing a distance of 1 meter. Okay, suppose this is the handle and there are number of link. How many? 1, 2, 3, 4, 5. After 5 link there will be one oval ring. Again it will be continue, and after each 5 ring there will be one oval ring. So this is how we measure the distance with the help of chain, that these oval rings will be counted directly. 1, 2, 3. So it is representing 1 meter, 2 meter, and so on. Okay. Now when we come to this, let me raise this. When we come to this part, now it is very tedious to calculate distance 1 meter, because if it is having a too large area and distance is very large, so it is very difficult to count one by one. So there is a one shortcut there, that there are tally rings that are present at a gap of 5 meter or 10 meter. Now how to come to know that, how it will be shown that it is 5 meter or it is 10 meter. So always remember that you can see here, this is brass ring or tally ring, and it is having a two head. So when this brass ring is present at a gap and it is having two head, it is represented at a 10 meter gap. So always remember, this is a single head is present at 5 meter and double head is present at 10 meter. So this is single head and this is double head. So you have to directly count either single head or double head. Directly you can calculate. Okay, so that is the basic idea about the chain. So you should remember that what is the smallest element of chain is link. And that link is of how much? It is of 20 centimeter. And if you know the dimension of a one smallest unit, you can multiply and you can get the total length. Okay, and number of links too. That question is asked many times in exams, so you should remember. Now next one is different types of tape. As I discussed, that chain was very heavy and it was having a number of errors too, because there is temperature difference in summers and winter. So whatever the calculation we do, that is having a certain errors due to temperature and due to sag and pull. So to avoid such errors, we have a new instrument that we used for the measuring the distance is basically a tape. Okay, so again there are different types of tape. The first one is cloth tape. Cloth tape is also known as linen tape, and it is made of cloth, and but is its width is how much? 15 mm. So you should remember that 15 mm wide is the cloth tape. Then we have metallic tape in a market also, you have seen many time too, that it is made of a brass and copper. Then we have steel tape too. It is made of steel and its width is in between 6 to 16 mm wide. Basically, you can see that this is the width of a tape, and you can see the numbering on it. These are the dimensions mentioned. So it is very easy to measure the distance. As in case of chain, it was very difficult, but in case of tape, it is very easy. Okay. So now the last one is invar tape. Invar tape is basically a made of a alloy. Alloy is basically a mixing of two metals. So what is steel and nickel? They are mixed in a proportion. So 64% of steel is there, and it is having a very low thermal coefficient. So this is all about tape. At present we use tape only because it is more accurate as compared to chain. Arrows are also used there, and this arrow is having basically a circular head, and it is having a sharp nose at the bottom point, and the diameter of this arrow is how much? 4 mm. You can see that this is the diameter of an arrow, and it is how much? 4 mm. And one end of the arrow bent into a ring of a diameter of 50 mm. So what is this? Circular ring is having a diameter of 50 mm, and the overall length of this is the overall length of the arrow, and it is how much? 400 mm. And what is the use of this arrow? Suppose this is the ground and we want to mark the station point. So what is, we can just put this arrow in a ground, so it will give you what, that this is station point 1. Suppose this is our station point 2, we have to just insert this arrow inside the earth. This is arrow 2. Now we can easily place a ranging rods at this point. This is A point and this is B point, and this distance can be measured, this distance A and B. Okay, so this was use of arrow. Okay, moving next, ranging rod. So I already discussed that this vertical bar with a flag is known as a ranging rods, and it is having a alternate color of white and red band. What is this white band? And this is red band, white, red. And what is the standard height of these ranging rods? It in between 2 to 4 meter. So you should remember these height because it asked in objective questions too. And red and white band of how much? It is of 20 centimeter. So ranging rods are, now next one is wooden peg. Wooden pegs are also used for indicating the position of the survey points or the final points, basically main station point. So it is having basically a square head, and its bottom part is having a pointed nose. So its standard height is basically how much? 15 centimeter, and the square is size in the range between 2 to 5. So if this square box is either it is of 2 into 2 centimeter, or either it is 3 into 3 centimeter, or 5 into 5 centimeter. Okay, so these are the basic dimensions that you have to remember, and it is made of wood basically. Now procedure of chain surveying. Procedure of chain surveying is basically including a two process. The first one is ranging process and the second one is chaining process. Now you can see here in this diagram that we are measuring a distance between these 2 points. This is A point and this is B point. So these are the ranging rods. These are placed in between. Now what is that if distance is large, because we have a chain of only 20 meter, and if this distance is more than 20 meter, then how you will measure? You will not get the accuracy. So what we have to do, that we have to establish a intermediate point. See here, so you can see here that this person is guiding this person until it is coming in the straight range. So basically this process is called basic what? Ranging. Okay, ranging is what? That the process of making all the points in a straight range. You can see here now point A, C, B and D. These all points are in a straight range. So this process is basically a ranging. When ranging is done, then it is very easy to measure. We have to just place the chain and we have to count the number of tally rings. We can easily get the distance between this point A and D by placing the chain in between, and we can count the number of tally rings. That will easily give you the idea how what is the distance between these 2 points. Okay. Now, when we do ranging, it is again of 2 points because topography challenges are there. So, suppose if we have a simple plain area, there is no obstruction, and these 2 points are visible to each other. Suppose this is point A and this is point B. So, this is very simple. These points are visible to each other. So, we can directly do a what ranging here. This is the ranging, and then we can lay down the chain here and we can find out the distance between A and B. So this process is basically called a what? Direct ranging. You should know that in which cases we have to use direct ranging. When the 2 points are having a clear visibility, we can see both points, and it is having a small area or plain area. So in that case we can use direct. But when we talk about hilly area, such type of conditions are not possible. Suppose this type of topography is there. Suppose this is point A and this is point B. This is one station point and this is second station point. Now person standing at A is not able to see person standing at B. So in that case, what we have to do, we have to establish some intermediate points. From there, these two main station points are visible to us. So this is point C and this is point D. This is point C and this is point D. Now with the help of approximations or with the help of intervisibility, we have to bring the points on a ground and we will measure this distance A and B. So this type of process is basically called a what? Indirect ranging, or it is also known as reciprocal ranging. So this question is again asked many times in exam. So same thing is I discussed with a diagram that this is a direct ranging. You can see that this is the plain area and directly you can measure the distance. But when we have a hilly area, in that case these 2 points is having two intermediate points and indirect ranging is done and these points will be interpolated to the ground and then distance will be measured. Okay. What are the technical terms of chain surveyings? So what are the basic things we have to use here? The first one is baseline, tie line, check line, main service stations, tie stations, offsets, range tie, check tie, and location sketches of our survey stations. So you can see a diagram here. Let's suppose this is the main area. Okay, and what is, there is a one station point again and is joined with this. Now what is baseline? It is the line which is running through the middle of the area so that we can have all the details. I will just draw a one line, one example here. Let's suppose this is the area and we have to calculate the detail of this area. So what we will do, that we will take a main station point A and we will take a main station point B. So what is main station point? Is main observation point from where we have to take the observation. So what is the line running between these 2 points is basically a baseline, and it is also known as a reference line. So you should remember that this is the line which is running through the middle of the area. Now from this line we will calculate all the details. Now suppose if one object is here, one object is located here, one object is located here. Now we will take other points here and we will take a either perpendicular distance or we will take a oblique distance to this object to identify the location of this object. So basically these are called what? Offsets. Perpendicular offset, and if it is making some angle from baseline, so it is oblique offset. So you should remember what is offset. Offset is of two types, perpendicular and oblique. Now what are the tie stations? check lines. What is when we have a different lines in a ground, so basically we use a one alternate line in between so that we can check the accuracy. So this line is called basically a check line. This again check line, and one is their tie line. Suppose when 2 point observations are very long, so in that case we take another point and another line in between. That line is called basically a tie line. Okay, these are very basic details that you can go through books also. Now, method of chaining on a sloping ground. Now, what is if we have a plain area, it is very easy to do ranging and chaining because it is plain area. Okay, we can easily measure the distance between A and B. But what if it is a slope area? Now, if this is point A and this is point B, how to get the distance? Because we required a horizontal distance between A and B. If this is having a slope, then how we have to measure? So this is done with the help of two methods we have. First is direct method and second is indirect method. Direct method and indirect method. Direct method is step method basically, and second one is clinometer method, indirect method. See, this is the direct method. You can see that suppose this is point A and suppose this is point B. Now we want to measure the distance between A and B, horizontal distance, but it is having a slope. So what we have to do, that we have to take a straight horizontal thread here, or we have to drop the plumb bob at this point on a ground and we have to mark it here. So now we can place a tape here and we can measure a distance of what? AP1. Okay, so this is the first step. Now from this plumb bob point that is drawn on our ground, we have to again take a straight line up to a certain distance. Suppose this is point P3. So now next distances we have to measure with the help of tape again, that is P2 to P3. P2 to P3. Now again we will drop a one vertical plumb bob on the ground, and again from this point we will take the next distance up to the last distant point. So this is basically a P4 to P5. P4 to P5. Okay. So this total distance will give you what? Basically a distance between A and B. AB is equal to AP1, P1, P3 plus P4, P5. So this is basically a direct method, or we can say. Okay, next method is indirect method. Now indirect method is indirectly we are measuring the angles and we will use a trigonometry here, and then we will calculate the horizontal distance. Now you can see here that in indirect method we have to calculate the slope, and that slope is calculated with the help of this instrument that is known as clinometer. Okay. Now in this case again we use two methods. The first one is by measuring the slope with a clinometer, and the second one is by applying the hypotensial allowance. Now in this case, what is, suppose this is the ground, you can see that this is the ground, and suppose this is the point on a ground and it is C, and this is the point on a higher elevation and this point is B. Now what is this? CB is on an inclined ground, but we required a horizontal distance between C and B. So this is the horizontal distance basically CB. Now in this case what we can do, that we can measure with the help of chain this slope distance between these 2 points C and B, that we have to just directly lay down the chain and we can have the value of L. Now what is, we have to calculate the theta. Now at this point we have to just lay down the tripod stand and we have to just fix this instrument clinometer, and from with this clinometer it is having a one telescope, or it is having a cross here. We have to just see through this, and what is, until this point is seen. Okay. Now what is, we have to just calculate the angle from the baseline, that how much angle it is having. Now simple, we have to use a geometry concept here. Simply like we have this. So in this case what is, we have to use, because we have to calculate base, so we have to use this formula, like cos theta is equal to base over hypotenuse. Okay, so in this case, what is CB? Cos theta is equal to base is what here CB, and what is hypotenuse here? Hypotenuse is L. So CB is basically what? L into cos theta. So this is the formula that we will use to calculate the distance between A and B. This horizontal distance AB will be calculated on this hypotenuse and this alpha angle L dot cos alpha. I'm writing a alpha here because angle is mentioned alpha. I'm not taking theta here. Okay. So this is the indirect method. Now next one is by applying a hypotensial allowance. Now what happened that when we use this method, in this case, what happened that we use trigonometry. So this is the distance C and this is the distance B. But in triangulation it is exact straight line, so you always get this distance. Basically this is B. Okay, this B point and this is B on a ground and this was the angle theta. So earth is spherical, so basically we get this reading, but actually we required this reading because earth kya hai? Spherical. Okay, so in this case what is, we have to subtract this reading from the calculated readings because this is the error, because earth is spherical, it is not straight, so we have to minus this dash error BB. uh, B1C, you can get a name, whatever according to your requirements. Okay, so I'm just writing a BB here, but in this statement it is mentioned B1C. So it is opposite, that this point is B and this point is C. Okay, let me change that this is point C and this point is C, C1 dash, and this is C. So how to subtract this B1 dash? Again we have to use geometry here, and that hypotensial allowance will be how much? It depends upon the difference between the point C and B. We should know the RL of C, we should know the RL of B, and we should have a value of what? H here, the vertical difference between these 2 points, H. So how to get this allowance? Because we have to subtract it, because जो हम रीडिंग लेंगे ग्राउंड पर दैट विल बी फ्रॉम दिस पॉइंट टू दिस पॉइंट. ओके, बट एक्चुअल में क्या है? अर्थ इज स्फेरिकल, दैट रीडिंग शुड बी अप टू B1 पॉइंट. Okay, so in that case we have to subtract this reading, so that allowance is how it is calculated. Again trigonometry will be used, h square upon 2l, or the second formula you can use for hypotensial allowance is L into secant theta into -1. Theta is already known to you, or alpha. Okay, so in that case what is, this is very important, it is asked many times in exams, what is hypotensial allowance? Due to the curvature of the earth, whatever the reading we take, it is always greater, so we have to subtract this value, and this value is called basically a hypotensial allowance. Okay, and its formula is h square upon 2l, or either it is L into secant theta minus 1. So whatever the value is coming, you have to subtract this hypotensial allowance and you will get the horizontal distance. Okay, because this reading was what, at in previous case it was L. So whatever the L you measured, you have to subtract the value of hypotensial allowance to get the accuracy. Now the third one is by knowing the difference between the points. Now what is, suppose this is point D and this is point A, and we have to calculate horizontal distance between A and D. So this one is slope distance. So now what if we know the RL of D point? RL is basically our reduced level, RL of C point. And suppose if we know the RL of B point. Now what is, we know the vertical distance because RL of D and RL of C. So RL of D minus RL of C, we will get this H3. RL of C minus RL of B, we will get H2. And RL of B minus RL of A, we will get this H1. Now what is, we will use Pythagoras theorem here because again it is making a triangle here. So if you want to calculate AB, so AB is basically a what? Perpendicular here. So Pythagoras theorem say what will be next, that this perpendicular will be what? L1 square minus H1 square. Okay. Similarly, how to get value of BC1? BC1 is equal to root of L2 square minus H2 square. Similarly, we have to get the value of CD. CD is equal to, CD1 is equal to root of L3 square minus H3 square. Now just add this distance AB, BC1 and CDB. You will get total distance AD. AD is equal to AB plus BC1 plus CD1. So this will give you basically a total distance between A and B. So this is the indirect method that we can use to calculate the horizontal distance in our hilly areas. Okay, so these are the three methods that we used. So thank you for watching this video, and if you like the content, please subscribe the channel for more technical information. Okay, bye.